Okay, so this is a continuation of the B lecture. I thought I could fit it into one lecture, but I didn't want to piss YouTube off, so I broke it into two here. So we're going to scan forward on this to the last slide. So one of the famous operations in working with assembly language is the notion of bit masking. Now the problem is, well, we'll talk about the problem in a second. So essentially it's based on the four things you can do with a bit. So you can do four things with a bit. You can set the bit, clear it, hold it, or toggle it. Okay, so these are just classic. I always say this over and over again. And the issue here is typically the microcontrollers are not bit addressable. So what you need to do is get the data you need to, whether it be a byte or a word or whatever, grab that chunk of data, and then you mask off the bits you want, or you mask off the bits you don't want, depending on how you want to say that. But I'm going to use these masking operations to essentially get at only the bits that I want to deal with. Now, once again, this has to do with the notion of input and output mainly. Okay, so the idea, if I have a single button that the microcontroller is monitoring, I can only input chunks of data at a time. So I have to input a whole big chunk of data, and then I have to mask the data to get at the button I'm interested in. So a lot of the operations, or all of the operations in a microcontroller, they're all kind of byte oriented or word oriented. So anyway, I have to use tricks to get at the bits that I am interested in. And so it's really straightforward. But once again, this is the reason I have to do this, is because microcontrollers are typically, they do operations on big chunks of data, and I have to live with that. But the way I get at little pieces of data is to mask what I don't want officially. So there's three ways to mask bits, or there's three ways to do what you need to do with these bits. Essentially, oftentimes I need to set a bit, or clear it, or toggle it, or hold it. And so here are the operations. The only way you can do this is if I want to set a bit, I OR it with a 1. Anytime you OR something with a 1, or a bit with a 1, that bit becomes a 1 no matter what it is. If I need to clear a bit, I AND it with a 0. Anytime you AND anything with a 0, it becomes a 0. To toggle it, I exclusive OR it with a 1. So these things are like carved in stone. That's the way you do it. You gotta get this memorized. We use it a lot. Typically, we used a lot in 133 also. So the issue here is holding a bit. So there's many ways to do that. Essentially, it's the opposite of these three ways. So if I'm holding a bit, I'm ORing it with 0, I'm ANDing it with 1, or I'm exclusive ORing it with 0. You'll see those operations come up. But these are the notion of doing nothing isn't really important as these operations here, as you'll see when we do some example problems coming up here. And so I think that's going to be it, almost. So we're going to get into some example problems after this, and I just don't know what to say about these instructions. And essentially, these instructions do operations that you're familiar with, and essentially the add and subtract, and or XOR, shift left, shift right. You're used to those, and of course arithmetic shift. You've seen those before. They're not a big deal, and I don't really know how to explain them other than to say there are instructions in the instruction set that do that, and I encourage you to look at the lab or the assembler manual or the cheat sheet and take a look at those instructions. So the two forms of these these operations that we're going to deal with are essentially these two forms right here. So I got in the habit of calling them a register form and a register immediate form. So the idea behind this operation here is like this. This is an instruction. It's obviously an add instruction because I have an add mnemonic there. But what it's going to do is take these two source operands, which is two registers. It's going to add the values in those registers and store that value in X1. So the value in X1 is going to change. The value in these two registers is not going to change. It's essentially reading X1, X2, and X3, storing the result, or writing the result to X1. So that's one form. The other form is it's going to take X3, add some immediate value to it, and then store that result into X2. So this is the immediate form. Always comes in these forms. That is a register value. It's not going to change. The only thing that's going to change is the value in X2. So a couple more things to note about that, but we're going to hold off on that for a while. So lastly here, some of these examples are pretty aggressive, seeing that it's only your second week with assembly language, but I simply want to give you a feel for what assembly language can do and how it does it. You have time to understand this. I would encourage you to work through these examples on your own. You'll see the solutions, understand the solutions. I'll go through them and explain my thought process too. I'm hoping that somehow helps. But that's about it. Next up is some examples.